Method 2 for making salts, I call it the general method. There's no name for it. It is the most common way that we make salts. And we use the reactions, the 4 reactions of acids, to do the making of the required salt that we're being asked to make. So my title slide says there, pick one of the 4 reactions of acids to make these salts. And before I carry on, remember this method is used where we've got salts that are soluble, salts that dissolve. Precipitation, which was my last video, dealt with insoluble salts, salts that don't dissolve. This one deals with salts that do dissolve. And you've got to pick one of the reactions of acids. Now there are 4 acid reactions that I spoke about in previous video: acid and metal, acid and base, acid and alkali. I mean, acid and base and acid and alkali are the same reaction essentially, but I split them up into acid base, acid alkali, and then acid carbonate. And those 4 reactions, we're going to use one of them. We're going to use one of them to make the required salt. And I'll talk you through one example and the ideas behind this. This is a really important lesson. This is asked about a lot on exam papers. So really get your mind around the chemistry and the ideas and the understanding behind this lesson. The example we're going to deal with is making copper sulfate. Now, excuse me if I spell it with a PH. I'm moving to spelling it with an F, but I sometimes forget. But copper sulfate is a salt. We need to use sulfuric acid to get the sulfate, and we need somehow to incorporate the copper into the name. And there are 4 ways to do that. You might think that we could react copper with sulfuric acid. I'll show you this in a minute, but we find there's no reaction. The copper as a metal is not reactive enough to react with any acids. So we cannot react copper with sulfuric acid. One of the main errors that pupils make is to choose copper and sulfuric acid, react them together, and the whole thing seems to work, and they do a whole method, not realizing that that fundamental reaction will not happen. So you can't pick it. That's why I put it in red. You cannot pick it, don't pick it. So what can we react? Well, we can react the base, the hydroxide, or the carbonate. And I've been into our stores and I've got those out to see and show you if we could react those with sulfuric acid. And with sulfuric acid, to make the required salt, my own preference is to use the carbonate, because when carbonates react with acids, they make salt water carbon dioxide. And so you get this lovely fizzing, and you know the reaction's going on because you see the fizzing. When the fizzing stops, you know the reaction has stopped. And that is something we need to get our mind around. We need to know when these reactions have stopped. We need to react, definitely, we need to react all the acid away. If we don't react all the acid away, then it's dangerous because there's acid left over, and that acid left over will make the salt impure. So you get impurities and safety. You must ensure the acid reacts away. And the way that we do that is we keep reacting, keep doing the reaction until there's no more reaction. And how do you know when there's no more reaction? Well, with a carbonate, the fizzing stops. And there's no more fizzing. And then you know there's no more acid. The other thing I want you to be clear about is this method relies upon the fact that the chemicals you're reacting with the acid are not soluble, because the extra chemicals we are going to be filtering out. And if they were soluble, they would mess up our salt, that introduce impurities, that go through the filter paper, etc. I'll talk you through the exact method later, but let me have a look at the chemicals and show you the chemicals we're talking about. I want to react sulfuric acid with either copper, that's a metal, copper oxide is a base, copper hydroxide, which you might think is an alkali, but it's not, it's just a base. But copper oxide, copper hydroxide, both alkalis, and copper carbonate. Now I've got 50 mils of sulfuric acid there, not there, and there. So 50 mils. Now, the reason that's empty, sorry, let me pull that back. 50 mils, empty, 50 mils. The reason that's empty is we have no copper oxide in our school to show you. So I can't do this, but if we had blue copper hydroxide, I could make it, but I couldn't be bothered. If we had it, then it would react. Now let me show you a reaction. So copper first. Copper here. You see that? I can bring the thing a bit closer and show you perhaps. There's absolutely no reaction. So we can't use copper, can we? Copper oxide. Let's try copper oxide. Copper oxide, black powder. You should know by now it's a black powder. Copper oxide. And there is a reaction. The black powder spreads out. The reaction is slow, but it is reacting, and it will, when it settles, when the black powder settles, it will leave a blue solution, and then we'll know reaction is happening. So we'll leave that, and we'll come back and look at it later. Pull this back. This is the copper hydroxide, which I haven't got to show you. And then, my favourite, the copper carbonate, we're expecting to see some fizzing. I hope you can see that fizzing. Put more in. You get more fizzing. More in. You get more fizzing. So out of these choices, my choice is this one because of the fizzing. Now the copper oxide, not only is it just a slower reaction, but there's no fizzing. We want to ensure all the acid reacts, and it's hard to know when all the acid there has reacted. Easy to know when all the acid here has reacted, because the next time you put some of this in, there's no extra fizzing. So what I really want to do is, I want to use that reaction. That reaction, that's acid with copper carbonate. I want to use that reaction to make copper sulfate. Now, let me show you that, if I just switch my video around, let me show you that is sulfuric acid. And I did have it heating earlier. If I get sulfuric acid hot, then of course the reactions are going to be a bit faster. Every time I let go it's going down. Just there. So while that's warming up, I'm going to get a beaker ready to do the reaction. I've got the beaker now. I can turn the Bunsen off. Because I think the acid is warm enough, I get this warm sulfuric acid. I can put 50 mils into that beaker. Just give me a minute to reorganize this to what I had before. Can you see that? Sulfuric acid with copper carbonate in this beaker. And I can put 50 of the hot acid in there. 50 mils of the warm sulfuric acid. That reaction will be faster. It'll be faster than the one that I showed you with the cold acid. And that's the reason we warm the acid up to begin with, just to make the reaction time smaller and shorter, and you get a spatula. See that, Fizzy? You get reaction. More Fizzy. Now you want to react all the acid away. Still some acid left. Has all the acid reacted away? Well, we'll know when we put some more in. If we put more in, look, Fizzy, the dust is making me cough. More in, more Fizzy. And you need to keep going. You keep going until there is an excess of copper carbonate. You've got to have excess of copper carbonate. Now, I'm just going to swap my spatula for a bigger spatula. And I'm going to use a smaller spatula just to stir it. Now that is getting to the point at which there's no more acid left. Now if we think there's no more acid left, then when we put some fresh carbonate in, there'll be no reaction. I'm going to put some fresh carbonate in now, watch. There wasn't a reaction. And if you look at the beaker, can you see at the very bottom, there's some green solid left. If you're not sure, then you know what? Put some more in. It doesn't matter because the copper carbonate does not dissolve in water. The extra copper carbonate, we want it, the extra copper carbonate, we want it to be at the bottom. Let me show you. I hope you can see that. Green copper carbonate is extra because we can see it there at the bottom. So the copper carbonate is present in excess the copper carbonate is present in excess. You can see the green solid at the bottom. The blue solution at the top is the copper sulfate forming and dissolving in the water. So the copper sulfate solution is above. The green solid at the bottom proves its excess copper carbonate. The excess copper carbonate is at the bottom. Even if I stir it up, there's no further reaction. The only way there can be no further reaction is if the copper carbonate, the green copper carbonate, is present in excess. And when I stir it up like this, can you see? I get a greeny blue. And when I leave it, I get a proper blue at the top and green at the bottom because copper carbonate is green. Right. I want to separate the copper sulfate solution from that, and I'm going to do that by filtering. So I'm just going to put my video on pause while I get a filter paper set up. Okay, carrying on then. I've got that solution here. Can you see where the copper carbonate has settled at the bottom? I want to get the solution above. I've got a conical flask, a funnel, and some filter paper which I can fold in half again. Pick 1/4. Make sure you pick where my finger is, there. Don't pick this, because that solution will just go through. And pour through there. Can you see? That's the excess copper carbonate. Now that excess is really important. You must have excess. Excess ensures all the acid has reacted away. If there was acid there, A, it would contaminate the crystals, and B, I'm going to boil this. You don't ever want to be boiling acid and concentrating the acid as we are going to do. The copper sulfate, the blue copper sulfate solution coming through is the salt solution. And we're trying to make copper sulfate. So we're going to get the copper sulfate out of that solution. And we're going to do it by crystallization. Now that's a method I've mentioned in previous videos. Now we could wait for that to finish, but because I'm a bit impatient, I'm just going to move that off there and carry on with this now. What I'm going to do is to heat this like that. The idea here is that we boil off the water. We boil off the water to concentrate the copper sulfate. Now normally we boil off about half the volume. So we're going to keep it there and heat it until half the volume has boiled off. And when it has, we'll come back to it. So we'll come back to that and we'll finish the method. But I hope you can see, out of the options of the 4 reactions of acids, out of the options, I like the carbonate one, but the base works just as well. The important thing is you're going to keep reacting it. This is the base, look. That was the cold acid with the copper oxide base. You see, there is bluiness, like you are making copper sulfate. The reaction was slower, there was no fizzing, but that reaction can be used. You keep adding copper oxide, keep adding it, keep adding it, keep adding it until all the acid reacted away, and then you filter, just like you saw me do there. Now, I just want to show you this. There, look. Can you see that boiling away? The volume will get less and less and less and less. And the blue coloration will get darker. And the solubility of copper sulfate in water, the solubility, eventually when there's less water, the solubility will be exceeded. When the solubility is exceeded, then we start getting crystals. That's why the method is called crystallization. And you can see on the side here, those are crystals forming on the side arm. So when it starts doing that, then it's time to turn the Bunsen off. Bunsen is now off. And we leave it for crystals to form. And we leave it for days. We leave the crystals to form. So coming back to my PowerPoint to teach you the ideas. What is this general method? And there's about 8 points to it. You need to learn this method. So we were trying to make copper sulfate. Pick the correct acid. Now for copper sulfate, the correct acid was sulfuric acid. But if you want to make a nitrate, use nitric acid. If you want to make a chloride, use hydrochloric acid. If you want to make a ethanoate, use ethanoic acid. It depends what salt you're trying to make. Pick the correct acid. Now, warm it up if you want to speed the reaction up. Pick the correct second chemical. Make sure if it's a metal that it will react. If it's a base or a carbonate, you can be sure it will react. Add the second chemical. Add the second chemical a little at a time with stirring and continue until the second chemical is present in excess. Now that's really important. More than enough. You've got to get to that point of having more than enough. When you've got more than enough, then you filter and keep the filtrate. That's the stuff that comes through the filter paper. That will be the salt solution that you want. Boil the salt solution to concentrate it, which is what I just showed you, until crystals start to form. And that's crystallization. Leave that solution. Leave it for days. Leave it for days for crystals to form slowly. And then after 2 or 3 days, normally I leave it over a weekend. And then we get back to the next lesson after the weekend. The class then filter. They filter that solution because there'll be solid crystals in there. And those solid crystals, they put in a desiccator. If you don't know what one of them is, I've explained it in my previous video. And put it in a desiccator to dry the crystals. That method is the general method, and I want you to learn it. Now I've got a flow diagram here into the apparatus. Sulfuric acid, and we added the chemical, added the chemical, added the chemical until it was present in excess. Then, when it's present in excess, you filter, and here they put copper oxide with sulfuric acid. I used copper carbonate, but here they're black copper oxide going in, present in excess, and then having got the solution, they've used an evaporating basin to concentrate the copper sulfate solution. And normally, as I say, my instruction to a class is boil till you've got about half the volume, and it will then look pretty deep blue. When it looks deep blue, crystals are starting to form. Then you stop heating. Then you leave it. You leave it for days. That is leaving it for days. Copper sulfate crystals form. After days, you filter again. Now, a lot of people, when they write the method, they forget this second filtering stage. You must talk about filtering again. And that's drying by putting in a desiccator or patting it with filter paper. If you understand that, then let's discuss how we might do this. Say the exam board sets a question, they want you to make magnesium nitrate. What would you use? Well, definitely you'd need nitric acid and react with magnesium as a metal, magnesium oxide, magnesium hydroxide, or magnesium carbonate. They are the four reactions. Magnesium is reactive enough. So any one of those four reactions would do. If it was me personally, I'd want the ones that fizz. So magnesium carbonate or magnesium. The fizzing will tell you when they're present in excess. Now, how about zinc chloride? Well, to make the chloride, you need hydrochloric acid. And again, to get the zinc, you need zinc or zinc oxide, zinc hydroxide, or zinc carbonate. And all of those would react. And again, my preference would be either zinc carbonate or zinc, because they fizz when they react. Well, if you want barium ethanoate, well, ethanoate is the salt of ethanoic acid. And again, you would pick one of the four reactions. And again, I would pick barium carbonate. I would pick barium carbonate because I know that that will fizz. And I'll be able to know when I've got excess. Right, so that method, the general method, I want you to learn it. It is the most commonly asked about method. There are three methods: precipitation, last video; general method, I call it this video; and next video I'm going to deal with titration. And the three together you need in your repertoire, and you need to pick the right one to make the right salt whenever it is asked of you. Okay, so see you next video, and I'll do the final titration method for making salts that you need. See you then.